Welcome to the channel. I'm Carlos Ortega, and I'm excited to explore the amazing worlds of physics and chemistry with you.
Next time you're sitting in a doctor's office filling out paperwork, look closely at the intake form. You'll likely see a box asking for your weight, and you'll probably fill it in with a number like 70 kilograms. Answering a question about your weight with a number in kilograms is a massive scientific error. We do it every day, but the language we use completely misrepresents physical reality. To see the difference in action, think of a classic parlor trick. When you pull a tablecloth out from under a set of heavy dishes, they stay put. They have an intrinsic resistance to being accelerated horizontally. That property is mass. But if you push those same dishes off the edge of the table, they plummet downward and shatter into pieces. That invisible downward pull is called weight. Now, let's take a person with a mass of 50 kilograms and send them to the moon. Suddenly, their measured weight drops drastically, reading as 6 times lighter than it did on Earth. So, did this person physically lose large portions of their body during the trip? No, the amount of matter stayed exactly the same. To understand why the measurement drops, we have to separate what a person is from where they are. In physics, mass is what we call a scalar property. That means it is purely a magnitude, an absolute, unchanging amount of physical matter contained within a body. You measure mass by comparing an unknown object against a known standard mass. This concept is so foundational that the modern kilogram isn't based on a physical cylinder anymore. It is mathematically defined by the universal Planck constant. Weight is completely different. It is an extrinsic vector property. A vector has a specific direction. Weight is not physical stuff. It is an action. Specifically, it's the downward force exerted on an object by the gravity of a celestial body. Because it tests resistance to a gravitational pull, you don't measure weight by balancing it against a standard block. You measure that downward pull in newtons, using a spring mechanism. This means the standard scale in your bathroom is technically lying to you. The internal spring mechanism actually measures the newtons of force you're exerting on it, but the display translates that force into kilograms of mass, assuming you happen to be standing on Earth. This equation shows exactly how these two properties interact. Weight equals mass times gravity. Here on Earth, the local gravitational acceleration constant is 9.8 meters per second squared. So if we plug in a mass of 50 kilograms, we get a heavy downward gravitational pull. But travel to the moon, and that local gravity drops to a very weak 1.622. Notice how the resulting weight arrow shrinks drastically. Even as that weight plummets, the m in the equation, the 50 kilograms of physical matter making up the body, does not shrink or change at all. Weight is a mathematical victim of the cosmic environment. Your mass is entirely immune to where you are in the universe. This diagram of a solid block demonstrates what is known as an extensive property. Because mass is extensive, the only physical way to change it is to literally chop off a piece of the matter and remove it. Weight, however, changes constantly. You don't even have to leave the planet. Just taking a flight or climbing a mountain puts you further from Earth's center, slightly lowering your weight because the local gravity weakens. Your mass is uniquely yours. It is the absolute, unchanging inventory of atoms that build your body, regardless of what the rest of the universe is doing. Weight isn't a property of your body at all. It is nothing more than an invisible, temporary tether between your atoms and whatever planet you happen to be standing on.